Welcome everyone. Today we are going to review graphing linear functions. So we're going to start with slope-intercept form. So reminder, these are in the form y equals mx plus b. So the value touching the x is your slope, and the value that's being added or subtracted is your y-intercept. And we always start with the y-intercept when we graph in y-intercept form. So looking at our first equation, we've got y equals 2x minus 3. So we really like our slope to be a fraction. So hopefully you know that you can always put a 1 underneath the value to make it a fraction. And then this negative 3, that is our y-intercept. So we're going to start with graphing negative 3. So I'm going to put a point on the y-axis of negative 3. And then 2 over 1 is positive. So positive slopes go up and to the right. So whenever it's positive, it's going to go up to the right. So we're going to go up 2 to the right 1, up 2 to the right 1. You could also start and go down 2 to the left 1 to continue that pattern. And once you have 3 or 4 points, you can draw a line through them. Make sure you put the arrows on to make it a line. The second one's a little bit different. We still have our y-intercept at 1, so I'm going to put a point there. But this time our slope is negative. So if it's negative, instead of going up and to the right, you go down and to the right. So negative slopes should look like that. So we're going to go down 2 to the right 3. If I try to do it again, I go off the graph. So you could also go up 2 to the left 3 to continue the pattern. So it's all about patterns. But negative should always go down and to the right. Positive should always go up and to the right. So this equation is slightly different. This is called standard form. So standard form of a linear equation is when you have the x and y on the same side. So there's two different ways you could approach this. My favorite way is when both of the numbers, when like basically what it equals. So this 12, if it's divisible by both the x and the y, what you can do is you can solve for your x and y intercepts. So to solve for the x-intercept, you plug in a 0 for y, because we know for an x-intercept, it's going to be a number, comma 0. So if 0 gets plugged in for the y, that means this y value is totally gone. So what I can do is take 2x and set it equal to 12, and then solve that for x. So x equals 6. So that means my x-intercept is the point 6, comma 0. So on the graph, I could put a point at 6, 0. Then if I wanted to solve for the y-intercept, we know y-intercepts are of the form 0 and then the y-intercept. So that means 0 gets plugged in for the x. So this time you take off the x value and you keep the y value. So you're going to do negative 3y equals 12. So if you divide by negative 3, you are left with y equals negative 4. So that means our y-intercept is the point 0, negative 4. So I could graph that point, and then we could draw a line through it, and that is our function. So that only works if the number that it equals is divisible by both of these numbers. So if that's not true, we have to approach it a different way. So let's look at one of those examples. So here, 12 is not divisible by 5. So our other way we could approach this is we could rearrange it and put it in slope-intercept form. So that means we're trying to solve for y. So if I wanted to solve this for y, we want to get y alone. So I'm going to start off with moving the x. So these are like those literal equations that we practiced where you just rearrange the equation. So we've got negative 3y equals, I like the x to go first, so I'm going to write negative 5x, and it's a positive 12, so plus 12. Then we can divide everything by negative 3 to make that y by itself. So y equals 5 can't be divided by 3, so what we know a negative over a negative is a positive, so a positive 5 over 3x. 12 divided by negative 3 is negative 4. So now we're going to graph this equation. So we know that negative 4 is our y-intercept, so I'm going to start at negative 4. And then my slope is 5 over 3, so I'm going to go 1, 2, 3, 4, 5, 1, 2, 3 to the right. And then again, up 5, to the right 3, and put a point. And then we can draw our line. So that is when the number that it equals is not divisible by one of these numbers. So like if you divided it by 5, you'd get a decimal, so that's not ideal because it's harder to graph. So you want to rearrange it into slope-intercept form. The last thing we're going to talk about are special cases. So when you have a special case of x equals 2 on the graph is right here. However, we want to graph everywhere where x is 2. So here x is 2, here x is 2, here x is 2. So all of these points that line up with x is 2 are true when x is 2. So that would make it a vertical line at x equals 2. So x equals equations are always vertical because it's everywhere where that is true. And it also has a special slope. So what we call that is a slope that is undefined. So vertical lines have an undefined slope. Y equals -3, you'd go down to y equals -3, and then you want to touch everywhere where y is -3. So if you go to the right of that, that's still where y is -3. If you go to the left of it, that's where y is -3. So that's going to create a horizontal line at y is -3. So I think of horizontal to remember that. Hold on, I can't talk and spell horizontal line. So the horizon is like a horizontal line, so that's what reminds me that it's horizontal is flat. And for these horizontal lines, that is, the slope is 0. So your slope would be 0 when you've got a horizontal line. All right, those are the types of graphs we're working with today. So why don't you try your practice and see how you do.